So today we're going to solve equations that you haven't really seen yet. Every time we've solved equations, you know, the x squared terms go away and we just have x's. You know, you add and subtract to get the variable by itself, and x equals a number. Today it's not going to be that simple, okay? We're going to look at what you do when you have a variable as an exponent. So it's not as easy as just simple adding and subtracting, multiplying and dividing to get the x by itself. You got to use some tricks, okay? Any questions? All right, let's just jump right in. Here is our first example. Now, before we even look at that, I just want to ask you a question. If I told you that 3 squared equals 3 to the blank, what would you put there? A 2, right? What if I told you 7 to the third equals 7 to the blank? 3. If I told you that 12 to the 25th equals 12 to the blank? 25th, right? Okay, so you can agree that if the base is the same, the exponent has to be the same in order for them to be equal. Everybody on the same page with me? Okay, let's go back to the notes. So right now, the base is the same. So what do I need the exponents to be? The same, right? They have to be the same. So I am going to solve this equation. What would make those exponents equal? So once the bases are the same, you just set the exponents equal, and that's how you get an equation. And yes, you are all correct. It is 4. I am more concerned that you understand from here to here. Does everyone see what I did there? The bases were already the same, so I just made their exponents the same. What are your questions? All right. Are the bases the same? No. We can make them the same. Which one are we going to change? The 9. What's another way I could write 9 so that it matches a base of 3? 3 to the what would make a 9? So I'm going to rewrite this side as 3 to the second to the x. Do you see what I did there? I rewrote the 9 as a 3 squared. Okay? Everyone see that? Now, I know that when I have an exponent to an exponent, I just multiply those. So this is 3 to the 2x equals 3 to the x plus 2. Everyone's still agreeing. Mm-hmm. Now the bases are the same. I can make the exponents the same. 2x equals x plus 2. That's what I'm going to solve. Subtract the x from both sides. 2x minus 1x is 1x, and that equals 2. What are your questions? Yes.
Could you change the 3 to 9?
You could, but you'd have to use fractions as the exponents. Yeah. How would we write the answer for the last one? X equals 2? We're just finding the value of x. So once you solve for x, you're good. All right, here's number 3. I want them to have the same base.
So it'd be no, the 8.
What about 16? No, that wouldn't work.
Someone says something. So do you agree that the number 8 is the same as 2 to the 3rd? Okay, so can we write 4 as 2 to the something?
Yeah.
To the 2nd, okay?
So you change both.
You can change both of them to have the same base. Okay, so instead of 4, I'm going to write 2 squared to the 2x. Instead of 8, I'm going to write 2 to the 3rd to the x minus 2. Okay. Before I drop the exponents, I'm going to multiply them out. So this is actually 2 to the what? 4x equals 2 to the
3x minus 6.
minus 6. Yeah, you kind of got to give them both the 3. Okay. I'm going to give you a second cuz that's a lot. What do I do now?
You said literally just 4. Yeah.
4x equals
3x minus 6.
3x minus 6. Then what?
Subtract 3x.
And x equals negative 6.
It's on 1 page.
Okay, so I know what? Anyone having any thoughts?
3 people left. 242.
So 3 to the something probably makes 243. Is that what you're saying?
Yeah.
Okay, but it's in the denominator. So it's going to be 3 to the negative blank, right? We just had to figure out what the blank is.
27.
So let's just start making a list. What is 3 to the 1st? 3. That ain't it. What's 3 squared? 9. What's 3 to the 3rd? What's 3 to the 4th?
You got me right there. It's
It's the
7 something. 80, yeah, I said that. 81.
Okay, and 3 to the 5th? 243. Okay. So this is going to be 3 to the negative 5th. It's negative because we got to get it out of the denominator. And then 3 to the 5th is 243. That's how we got that far. Anyone confused on what I'm doing at the moment? Okay, so the left side is just the same thing.
So it'd be 3.
On the right side, I have 3 to the negative 5th power. Now we're good to go, right?
4x
So 4x minus 9 equals negative 5.
plus
So yeah, go ahead and add that 9. And then divide by 4, and x equals 1. Now, if you're ever like, I don't know about this, plug it back in. And in the calculator, you can do 3 and then this button. And then you probably want to open parentheses. 4 times 1 minus 9. Okay? And you'll get some big, long, crazy decimal, and that's fine, because then you'll clear the calculator, and you'll hit 1 divided by 243, and you should get that same crazy decimal. And if you don't, you made a mistake. What are your questions? Okay. Thoughts, anyone? What? I can't. No, we don't want to we don't want to take each one to the x power. We want to leave the x out there. All right, what are your thoughts? You guys are obviously talking about math back there, so what have you come up with?
How many times can one flip into 256?
So you want to see if 4 to the something equals 256. That's where you want to start?
Yeah.
Okay, so let's go through it. 4 to the first is 4. 4 to the second is 16. 4 to the third is 64. 4 to the fourth is I think it is, right? Because if you do 64 times 4, that's 6 and then 1 and then, yeah. Okay, so I can write this side as 4 to the fourth. That's not all the way helpful. What am I going to do now? You're close, but you have one word off. She said flip it and make the 4 negative. I don't want to do that. Yeah. When you take something from one part of the fraction and move it to the other, you're changing the sign of the exponent. So 1/4 to the x is the same thing as 4 to the negative x. Oh. Give it some thought. Process that for a second. Yeah. How about them apples? All right. So now I can put these guys equal, right? So negative x equals 4. Divide both sides by a negative 1, and x equals negative 4. What are your questions?
Yeah.
Are we good? Whoa. Hey, yo. I think we have 8 examples.
Yeah. Hey, you know the 4 to the I forgot what I was going to say. Let me repeat. Third is 64, and then 4 to the second is 6.
So you want to write this one as 4 to the third?
Yeah.
And this one as 4 to the second? Like that? Okay. So now I gotta I don't want to have parentheses before I drop my bases. You know what I'm saying? So 4 and then 6x plus 12. And then 4 to the 10x. All right, now we're good to go, right?
Wait, no, we're not. Okay,
All right, then what?
Subtract the 6.
I believe you mean subtract the 6x. All right, so 12 equals 4x. Then we divide by 4, and we divide by 4, and we have x equals 3. What are your questions? Can you sleep? No. Yowza. Oh, man. Well, we want to get just 1 5 as the base on both sides. So I'm going to go ahead and say that this guy is fine. What do I do when I have the same base being multiplied? You add the exponents. So this is actually 5 to the 3x plus 4. Whoa. If you're like, what is she talking about? What if I would have said like x to the second times x to the third? You know that that's x to the fifth, right? Well, all you did was add these two numbers. That's all I did. I added this and this. Now I can make them, so 3x plus 4 equals 70. Then what? Subtract 4 from both sides. And then divide by 3. And you got 22 indeed. We good? All right, last example of the week. How is a bracket different than a set of parentheses? It is the same thing. I was trying to set you up. So what do you think I should do here? Yeah, I need to multiply these two. So this is 2 to the 15y equals 2 to the 17y plus 1. All right, what am I going to do? Subtract 17y. Good. So negative 2y equals 1. Then what? So what does y equal? Negative 1/2.
I don't have room.
Today we learned to solve exponential equations, whatever that means.
Now, you just said, I don't know what that means. So you don't summarize something in words that you don't know what they mean. So today we learned... Now, someone just told me they don't know what that means, so we're not going to use that word. Today we learned to solve equations with what? Put it all together. With what?
And parentheses.
Exponents
You mean brackets?
that are what?
In the exponent that's what?
Variables. Very good. That's what I was going for. That variables are in the exponent in the problems we did today. We've solved problems with exponents. We did that yesterday. It was the last two examples. We haven't done ones where the exponents are variables or there's variables in the exponents. All right, here comes your homework.